Good morning friends. Today I am going to explain the one of the important topic in thermodynamics, that is work done in adiabatic process. So before going to calculate the work done in adiabatic process, first of all we should know what is adiabatic process. So what is adiabatic process? A process in which heat is neither enter into the system and nor leave the system. So the definition we can write: when a thermodynamical system undergoes a change in such a way that no exchange of heat takes place between it and the surrounding, then the change is known as the adiabatic change. So what is meant by the thermodynamical system? A thermodynamical system means a system, generally we are taking as a cylinder piston arrangement. Here this one is the thermodynamical system. A thermodynamical system means which consists of some temperature, some pressure, some volume, entropy. So such type of system is known as the thermodynamical system. So what is adiabatic process? So whenever heat is neither enter into the system and nor leave the system, such type of process is known as the adiabatic process. Okay, so to calculate the adiabatic work done in adiabatic process, let us take 1 gram mole of an ideal gas. Ideal gas means which obeys the gas laws, that is Charles law, Boyle's law. So we are taking here ideal gas, and that gas is expands adiabatically. Okay, that is heat is neither enter into the system and nor leave the system. Okay, now here initial state is we are taking Pi and Vi be the pressure and volume of the gas, and at state A. Here this one is the indicator diagram. So generally we are representing this in thermodynamics, a diagram is used to represent the gas states, that is known as the indicator diagram. So here the initial state of the gas is represented by A, where the initial pressure is Pi and initial volume is Vi. And when the gas expands adiabatically, so it reaches a point B, so where the final pressure is Pf and final volume is Vf. Now our aim is we are going to calculate the work done by the gas when it expands adiabatically from A to B. So for that purpose, first of all we have to consider a small volume C to D. So our intermediate state C to D. So first of all we will calculate the what will be the work done by the gas at from C to D. Then after that we have to integrate that particular value, we will get the whole one. Okay, so for just I wrote this one here, and Pf and Vf be the pressure and volume of the gas at state B, okay, respectively as shown in the figure. Now during adiabatic process the pressure and volume changes. We know that during this process pressure and volume will be changes. Now now we have to calculate the work done at some intermediate position C to D, and we have to imagine this here that is C to D, the pressure is remains constant. Okay, for a small change in volume dV from C to D, let pressure is remains constant. Just now I told you. So the work done by the gas during this small expansion is, so we know that what is the definition for the work done. So work is nothing but a force into displacement. In terms of gases we have to take force is what? Pressure, and displacement of the volume, displacement of the particles is taking in terms of volume. So that's why the small work done or small expansion of the gas can be written as P dot dV, which is indicated by the shaded area in the figure. Okay, now the total work done by the gas during the expansion from volume Vy to volume Vf. So from A to B we have to take the integration of this equation, that is W is equal to Vi to Vf P dot dV. Okay, let us take this is equation number 1. Okay, now for an adiabatic process, We know that in your previous classes we have studied about for adiabatic process p v to the power of gamma is equal to the k or some constant. So where gamma is nothing but it's a ratio of specific heats. So now we will calculate this one here where gamma is ratio of specific heat, that is gamma is equal to Cp by Cv. Now P v to the power of gamma for adiabatic process can be written as P v to the power of gamma is equal to some constant K, or P can be written as K by v to the power of gamma, and let us take this is equation number 2. So what is the first equation, that is here Vi to Vf P dV. Let us take this is equation number 1. Now we got the value for the P. Now we have to substitute the equation number 2 in equation number 1. So we can write from equation number 1 and 2 we can write here W is equal to the Vi to the Vf, and K by, in place of P we have to substitute the value of K by V to the power of gamma into dV. Now K is the constant, so we can take out K Vi to Vf 1 by V to the power of gamma dot dV. Now we have to integrate to this equation K, then this can be written as V to the power of minus gamma plus 1 by minus gamma plus 1, and the limits are Vi to Vf. Okay. Now again we can take this minus gamma plus 1 as a 1 minus gamma to the outside, then K by 1 minus gamma V to the power of 1 minus gamma, we can write Vi and Vf. So just we are modifying this minus gamma plus 1 to 1 minus gamma, and this is also 1 minus gamma. Next K by 1 minus gamma. Now we are going to substitute the limits here, Vf and Vi, that is Vf 1 minus gamma minus Vi 1 minus gamma. Next, now I am going to take the take this K to inside, so 1 by 1 minus gamma gamma, and this is K by here V to the power of 1 minus gamma. When you take to the denominator, it can be written as Vf to the power of gamma minus 1, and minus K by, and this is also Vi 1 minus gamma can be written as gamma minus 1. Okay. Now we know that already K is nothing but a constant, and this can be written, this is in this position final and this one is in the initial position, so we can write K as Pf and Vf to the power of gamma, and here K is equal to Pi and Vi to the power of gamma, or just simply we can write this K is equal to P of Vf to the power of gamma, and that is equal to Pi Vi to the power of gamma. Okay. Now when you substitute the value of k, here p of vf and here pi vi, then 1 by 1 minus gamma, this can be written as p of vf to the power of gamma by vf to the power of gamma minus 1, here minus pi vi to the power of gamma by vi to the power of gamma minus 1. Okay, now this can be written as w is equal to 1 by 1 minus gamma, and all are get cancelled here in this equation. In this equation, p vf and vf is we will get only p of, and we will get 1 vf to the power of minus 1. Here vf to the power of gamma, vf to the power of gamma get cancelled, only vf to the power of minus 1 is there. So when you take to this numerator, then it becomes vf. Okay, minus here also vi to the power of gamma and vi to the power of gamma is get cancelled, and we will get vi to the power of minus 1. When it goes to the up, then we will get pi and vi. Okay, so final equation can be written as here w is equal to p of vf minus pi vi, and this is known as the work done in adiabatic process. So when you take if the initial and final volumes be v1 and v2, similarly initial and final pressure P1 and P2, then the work done in adiabatic process can be given as W is equal to P2 V2 minus P1 V1 by 1 minus gamma. Okay, so this is the work done in adiabatic process. For more videos, subscribe my channel Physics. Thank you.